more points related to parallel plate capacitor. More points related to parallel plate capacitor. So first, this is the parallel plate capacitor. A and B are the terminals, and so if Q is the charge on the one plate, so another plate have charge minus Q. Let A is the capacitance, A is the area of the plate, and D is the separation between the plate. So already we have find capacitance of a plate is written as capacitance of capacitor C is equal to epsilon naught A by D. This is the capacitance already we have calculated. The first point. Since as we have found one plate is positively charged, another you are negatively charged. So because of the positive and negative charge, there is a force of attraction between the plate. So we will calculate how much the force of attraction between the plate. So force between the plate. Force between the plate. So as we know, force is equal to your charge into electric field. So what we will do, in this we will take charge of one of the plate and field due to other plate, and see both are your both having the same charge but opposite nature. So force of attraction will be like this. Force of attraction. So charge on the one plate is Q and field due to other plate is given as Q by 2A epsilon naught. This is the force. The force written as 1 by 2 Q square by A epsilon naught. This further can be written as 1 by 2 sigma square A by epsilon naught. Any one of the expression we can use, where sigma is equal to Q by A, and this is called your surface charge density. It is known as surface charge density. And when the force acting between the two plates, because of that force some pressure is there. So from that we can say the pressure also. So electrostatic pressure due to that force. Electrostatic pressure due to that force. So pressure is equal to force per unit area. So force per unit area, that is nothing 1 by 2 sigma square by epsilon naught. So this is the expression for pressure. So force between the plate can be given as 1 by 2 sigma square A by epsilon naught, while pressure between the plate can be given as 1 by 2 sigma square by epsilon naught. Now come to the next, energy. Energy is stored within the plate. Second point. Second is the energy is stored between the plate. So that we can say the energy stored means energy is equal to work done to separate the plates by distance d. So U is equal to your, as we know, force between the plate does not depend on the distance between the plate, that is constant, F into D. Already we have calculated force 1 by 2 Q square by A epsilon naught into D. So this is the energy stored, and as we know 1 by 2 q square, and C is your here this term. This term is also written as epsilon naught A by D, which is nothing, this is C. From here also we are getting q square by C. This is the energy stored between the plates. And energy density. Energy density, small u means energy stored per unit area. Energy stored per unit volume. Energy is stored per unit volume. So small u written as capital U by V. So that all of this energy which we have calculated here, that is stored between these two plates. So that energy here half q square d by A epsilon naught by volume. Volume of this part is your A into D. So A into D. So this is half q square by A square into epsilon naught. That further written as half q by epsilon naught A into square into epsilon naught, and this is nothing, it is the energy stored or a electric field. Where E is equal to your q by epsilon naught A, so where E is the electric field between the plates. So that formula is the resultant electric field between the plates. So energy density means energy stored per unit volume. So whatever total energy that is stored between the plates of capacitor, that is stored in this volume. So energy density can be written as U by V, and which is given as 1 by 2 epsilon naught A square, and this is very general formula. So energy density formula. So energy density U is half epsilon naught E square, is very general result, can be applied in all conditions. So this is very, very important result. So these are the some basic points related to your parallel plate capacitor. And next is your Kirchhoff's law as well as charging and discharging of a capacitor.